Welcome to solverfy.
For this problem, the equations to use are the ones defining the average acceleration as the change in the speed or the velocity over the change in time, and that when the rocket or the sled comes to rest, the final velocity is 0. So we only have the initial velocity in the x direction, or the change in time. And we're given the velocity, the initial velocity, in miles per second. And I suggest we convert that right from the get-go to meters per second. It's given to us in miles per hour. We should convert it to meters per second. 632 miles per hour. And then to convert it to meters per second, we need to multiply by the number of meters in a mile, which is 1609 meters per mile, and then also multiply that by the number of seconds per hour. So 1 hour has 3600 seconds, and this result comes out to be, whoa, sorry about that. The solution, the velocity, the initial velocity in meters per second comes out to be 282.468 meters per second. And now that we have the velocity in meters per second, we can compute the acceleration in which the rocket or the sled is brought to rest, and that's negative 282.468 meters per second over the time interval of 1.40 seconds. And this comes out to be minus 202 meters per second square. So this is the solution to part A of the problem. And then the solution to part B is the separation, or the length that the vehicle traveled before it came to rest, and that is equal to, we solve this from the final square minus the initial velocity square equals twice the acceleration over the displacement. We know that the final velocity is 0. We know the initial velocity, so the displacement, which is x final minus x initial, is going to be negative of the initial velocity square over twice the acceleration. And remember that the acceleration was negative to begin with, so we should get, once we enter all the results, we get minus 282.468 meters per second, and we square this quantity and we divide it by twice the acceleration, which is minus 202 meters per second square. We will get a distance of 198 meters, about 198 meters. And that's the solution to this particular problem.